question we are told that log b1 to the base a, log b2 to the base a and so on till log of bn to the base a are in an arithmetic progression. So what this would imply is that if you are just considering the first three terms of the arithmetic progression, log of b1 to the base a plus the third term which is equal to plus log of b3 to the base a is equal to 2 times the second term which is log of b2 to the base a. You can simplify the left hand side to equal log of b1 into b3 to the base a. This is equal to log of b2 square to the base a. We can cancel log a on both sides. So essentially what it implies is that b1 into b3 is equal to b2 square, or b1 and b2 and b3 are in a GP. We can extend the same logic to all the terms of the arithmetic progression. So b1, b2, b3, b4 dot 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 till bn are in a geometric progression. This is something that is interesting to note. Whenever the logarithms are in a arithmetic progression and if the base is the same, then the arguments, that is b1, b2 dot 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 till bn, will be in a geometric progression. So now let us assume that the geometric progression's common ratio is say r. The first term is b1. So what is the value of b4 which is given to us? The fourth term of the geometric progression will be equal to b1, which is the first term, into r cube. This is told to be equal to 12. And what is the value of b7? b7 will be b1 into r to the power 6, and b5 will be equal to b1 into r to the power 4. And the difference between these two is given to be equal to 72. Now what this would imply is that b1 into r to the power 4 into r square minus 1 is equal to 72. What we do know is that b1 into r cube is equal to 12. So this implies that 12 into r square minus 1 is equal to 72, or the value of r into r minus 1 into r plus 1 is going to equal 6. We can figure out that the value of r has to equal 3, because 6 is equal to 1 into 2 into 3, the value of r plus 1 will equal 3, and the value of r is going to equal 2. Because 6, if you are expressing this as 3 numbers which differ by exactly 1, this is 1 into 2 into 3. So now what we can assume is that the value of b1 is equal to 12 divided by r cube, which is equal to 12 divided by 8, which is 3 by 2. We are required to calculate the value of b1, b3, b5 and so on till b19. b1 is equal to 3 by 2, b3 will be equal to b1 into r square, that is 3 by 2 into 2 square, that is 3 by 2 into 4, which is equal to 6. Similarly, b5 is going to equal 24. This itself is a geometric progression because b1, b2, b3 and all are also geometric progressions. But over here the common ratio will be r square because we are having a difference of 2 between the subscripts. So r square which is essentially equal to 4. So the sum of the first 10 terms of this geometric progression, because the number of terms is from b1, b3 dot 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 till b19, the number of odd numbers till 19 is 10. So the sum of the first 10 terms of this geometric progression is going to equal 3 by 2, which is the first term, into 4 to the power 10, because 4 is the common ratio, minus 1 divided by r minus 1, so that is equal to 4 minus 1. Remember that the sum of the geometric progression is equal to a into r to the power n minus 1 divided by r minus 1. In this case, a, which is the first term, is 3 by 2, r is equal to 4, and the number of terms is 10. If you are simplifying this, you can cancel 4 minus 1, which is equal to 3 over here. So this is essentially equal to 4 to the power 10 minus 1 divided by 2. You can use your calculator to figure out that the correct answer will be option B.